got to start the recording. Sorry about that. Great. So just as I was telling you, it's going to be recorded for future reference, just so you know. Yeah. So let's do a quick introduction here. Like I said, if you're missing Allerton Park, here it is. There's your building. There's Wing something or other. I never remember the names of the statues. But the gardens, I'm sure they look beautiful. It's probably a little too early for them to look really great, but it's always a nice setting. So if you're nostalgic for IMACC, there it is. So let's do a quick introduction here. Oops, not that one. Here we go. So we'll just go right down the line. Just how many years have you been at IMACC, and what's your favorite class to teach? So roundtable, start with you.
Hi, can you hear me?
I can hear you, yes.
Yay! My name is Rianti, and this is my second year of attending IMACC. And my favorite
Last year was your first year, wow.
Yeah,
Okay.
it was my first year. So I have been to Allerton for other reasons, but not for this, and I love it.
Yes, it's a great
my
setting,
favorite class to teach, that's a hard one. Like, yeah, it's very beautiful. I'm an outdoor girl. Favorite class to teach. I think right now so I teach a combination of I teach like a nice slice of my college. I'm at the College of Lake County, and I teach math for elementary school teachers, statistics, and trig.
Oh, that's a nice variety there, yes.
Yeah, and so I feel like whenever I get a little burnt out, a little dry on one of them, I'm like, oh, the other one's really fun. So I like having that grouping. So today I like teaching trig today. I think trig was a good one for this. I'll call this week was a good trig week. Yeah.
Sounds good. Yeah. Thanks, Dorothy. Abby, go ahead. This is the only time I'll make you talk, so.
Oh, I just counted it up, and I have been attending IMACC for 11 years.
11 years, great.
I've been really,
and your favorite?
Like,
and your favorite class?
That's challenging. I feel like they all have their little delights, and they're all their own pitfalls as well.
Exactly. Yeah.
Right, and so I would say
you do with Riante, you could just pick your favorite right now if you had to say something like what happened today or.
Oh, I'm actually not teaching right now.
Oh, okay.
No, this pandemic, it is what it is. So I couldn't do that.
Yes, exactly.
I feel like the LED is my favorite, even though it's the most taxing. So I have to.
Yes, I used to teach that many years ago, and I felt the same way. It was. Maybe it's the type of student you get in there or the material, but yeah,
it is
I have to agree with
exciting,
that.
but I
yes,
have to
it is.
It through the cycle.
Yeah, and it's got a purpose too, right? These are going to be future teachers. Gotta like it. Okay, all right. Thanks, Abby. Matt, go ahead. What year IMACC is this for you?
This is my first year. I
Great.
couldn't turn down the free 1-year membership. So
nice.
And
what school do you teach?
Oh, I'm at College of DuPage.
DuPage, okay.
Yeah, and I teach every fall. I teach linear algebra, and that's the course I most look forward to.
Nice. I'm also teaching that this term. I hope you have more students than I have. I have this many.
I've had that many on certain days for sure.
Oh, right. So welcome, Matt. Christopher, go ahead.
Hey, I'm Chris, and I've been coming to IMACC here for 2 years now, similar to Rianti, and I was thinking about the response to my favorite class. How about this one? My favorite class is whichever one I'm teaching right now.
There you go. It's nice to have more than one favorite. Sometimes it depends on the material.
A good answer.
Yeah, good answer. I like that. Great. Jenna, go ahead.
Hi. I've been to IMACC conferences off and on over the past about 10 years. Probably been to
Mhm.
like 3 or 4 of them.
Great.
I think probably my favorite class to teach right now, either finite math or stats.
That sounds good. Thank you, Jenna. I've lost track of how many IMACs I've been to, but I started going in 1992. So it's definitely more than 20. I'll just say it that way. And I have to agree with everybody else. My favorite class varies from day to day, semester to semester. I'm also teaching linear algebra right now, and it's fun even though I only have 2 students. So it's kind of challenging because I have one really good student and one so-so student. So kind of where do you focus? It's kind of in the middle there.
Do you do group work in there, John?
There's what?
I said, sorry, do you do group work with those two?
They have worked together, yes.
Yes.
So yeah, that'd be one, just to have them do all the work, that would be. But I'm also teaching a pre-calculus for the first time, and that's another class, kind of like the math for elementary school teachers class. Why are they there? They want to take calculus. So you do everything in there that needs to be done to get them ready for calculus. And we just did the graphs of the trigonometric functions today. So I like to kind of get them to, take a period and shift of one of those sine graphs and say, here, fill up the screen with one period and know exactly where to start and where to end. So I have a good time with that. I hope they understand the rationale for doing things like that. So, all right. So thanks, everybody. Let's go ahead and continue on here. As I said, this is like a continuation of what we talked about last year. So what I did last year was kind of talk about the calculus classes I introduced the technology projects into first. So these are just kind of some of the years I was doing it, all the way back to 2005. The ones I want to focus on today are the more current ones, since we actually have done more, even in the pandemic times, online, still able to do these technology projects. So for those who weren't here last year, oops, didn't even do that. Here we go. These projects are in conjunction with the rest of the work that you do in the class, so they're kind of graded separately. So you have kind of like a written component, and then these technology projects are another component to the grade, and they have to do a certain number of them before the grade is computed. So if you do a certain number of projects, then you have a certain percentage on the written work, you get a particular grade. That's why the original project was called contracting for calculus, because they know exactly what the grade's going to be, because here's your percentage, here's how many projects you did, here's a grade. So that's the story behind the name. So started in Calc 2, went to Calc 1, and then introduced them in Calc 3. So my most recent Calc 2 was summer of 2021. And I just did Calculus 1. That was an online class this fall. And I have been able to do them, not just in the regular in-person classes. I've been able to do them with the online classes and our online hybrid classes. I've been able to do them over the summer in a shorter time span. So I did want to give you some examples of what the projects look like, and then how they're kind of graded by showing you some examples of student work. So let's start with Calc 2. That was the, here we go. The one that I kind of talked about over the summer. So here is a project. This was the first one. I may have done a problem like this before. I like to call this one the pizza question. So calculus students are not like traditional students. They don't cut their pizza the same way as everybody else. So in calculus, you talk about areas. So they had to figure out, where do you cut the pizza so that these 3 areas are the same. So that was the question. And then there was an extension to that one where a fourth student were to join. So where do you change your cuts to make all four equal? So you couldn't do the usual like this. And so the idea, of course, is to get them to use technology. So here is a student and their first project. So R means revise. They had to revise some things. I wanted to show you this example because this student, they did the work with the technology, but as you can see, they wrote everything out. I think they used a compass here, but everything is written out there very nicely. If I asked them to correct something, I don't actually, correct it like a regular homework. What I would do is kind of point to something and say, could you tell me? A lot of times it's give me some more explanation here, or show me some more work, and where did you get this formula from? And if there's something that was incorrect, I'd ask them to change it. So there are a couple of things the student had to change. But as you can see, it's pretty nicely written out. I can read it. I don't expect them to type things up. So when they do a correction, they turn it back in, and I just make sure everything that I asked them to correct was corrected. And the student did verify their answer right here, which was nice. And then I asked them to do a little generalization. They were able to do that. And so you can see all their work here. So there's kind of a sad ending to this story. This student did very well in class. Took the final. This is an online class last summer. I found evidence that he used outside sources to do some of his problems. And that's one of the pitfalls. We're going to talk about that later. Students not turning in their own work. I don't know if you've run into this with the pandemic, but I have seen some of my test questions on Chegg. And I tried to take them all down, but one of the ones I left up was a question that was answered incorrectly. And there were certain students who went to Chegg and wrote down an incorrect answer and submitted it. And that's how I knew they were using Chegg. So the student that did not end well. So I now am doubting what I see here because I don't know if it's him or not. And that's one of the things, with an online class, even, with an in-person class, sometimes you don't know whether the student's actually turning in their own work. So nice work, but not a good ending to the story, unfortunately. Right, and then this is from Calc 1. So I'm gonna go to project number 3 here in Calc 1. I like this problem because this is for those trig fans. Here's a trig question. Modeling the number of hours of daylight in a particular city for a given year. Sounds like a good trig question. So they had to answer a question about a graph, and then they had to sketch a graph for the entire year. I expected them to use technology for that part. And then part 2 is it's an interesting function because if you look at the function, it gives you the number of daylight hours on June 21st. What's significant about June 21st? Summer solstice. So that's the maximum number of hours you're going to get in the Northern Hemisphere. So they had to put in latitudes as inputs, and then the outputs were sunlight hours. And of course, if you're above the Arctic Circle, what happens on June 21st? You get a lot of sun. Get a lot of sun. So they had to come up with a graph of this function. And so this student started off talking about this, and they graphed the function, but not the way I wanted them to. So I wrote a few notes on this, but you can see they used Desmos. That was one of the options they could. Did not identify the maximums and minimums correctly, unfortunately. And then for this function right here, I asked them to come up with some daylight hours for certain cities. So they had to pick one of their own, and then a bunch of these they had to do all the same. And the graph of the function, take a look at that. This is why it's a good calculus question. Look how it goes up, 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 up. And then what's happening right there? That's what makes it an interesting calculus question, because talk about derivatives in calculus. Is the function differentiable at that point? It is not, and they had to say why it was not differentiable there. So one of the challenges I thought was getting this graph. The student used Desmos, and they did a very good job with the graph of the function. So I asked them to correct it, and everything looked good when I looked at the correction. You can see how they changed the graph of the daylight hours. Here's your maximum, here's your minimum, looking good there. And then I think I had them do a couple of different things with this graph as well. But this was a student who used Desmos. So as I said, with the calculus question, looking at rates of change here, how the rates of change go up, 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 up. And then at this point, all of a sudden, you can't calculate anymore. And that's where that changeover happens. But you want the function to be continuous because that's what it should be. You take the latitude, put it into the function, you should get a corresponding output. We don't want any nice jumps in the graph. So that was the challenge for this problem. And the student did a really good job with that. And you can see this student mostly typed things up. I don't expect them to type things up, but if that's how they want to do it, especially now with them submitting things online, a lot of them want to type them up instead of writing them up by hand. Perfectly fine. I give them the option to do it either way. So P means pass. That means that they don't need to do any other corrections. It counts as an accepted project. So that was from this past fall. My current class, pre-calculus, I wanted to show you some examples from this class. So the first one I have them do is kind of an introduction to functions. So I had them graph some functions to see if they're one-to-one and work with compositions and inverses. So some nice basic stuff that you would find in college algebra and also pre-calculus. So technology to produce these graphs, they have no idea what these graphs look like at this point. They might know something about a third-degree polynomial. But this one, maybe something about a rational function, but this is introductory stuff, so that's pretty early in the term. And then they had to do an example of a composition and an example of an inverse. You may have seen Torricelli's law before. What I like about this problem is, in order to talk about an inverse, you have to restrict the function so it's one-to-one. This function is naturally restricted because it applies to the situation where the tank is draining. So there's a natural restriction that you could use here. And so when you take the equation and try to solve for y in terms of x, that plus or minus pops up. But then it goes away because of the restrictions. So the student who did this one the first time, they used Desmos, I think. Yeah, so they graphed them for the first part. Here's the second part with the car prices. I asked them to make a change because we shouldn't be talking about negative numbers for the outputs here. And then when they did Torricelli's law, I tried to ask them just that thing I was telling you about. Why is it -4 square root of x instead of 4 times the square root of x? And that's that whole switching x and y and trying to get the y value by itself. And so when they graphed it, they graphed too much. So I asked them to change that. Their second submission looked good. So when I looked at their second submission, they made all the changes that I asked them to. There's your graph in the positive region. They included the part about the plus or minus. And then they not only graphed the inverse, but they graphed the original function, which was kind of an added bonus. I didn't expect them to do that. This is Torricelli's law, starting at 100, ends up at 0. So the inverse starts at 40, ends up at 0 at 100. So you can see this person used Desmos. So the second question. So think about how college algebra progresses. You talk about functions, then linear functions, and then quadratic functions. So the second technology project, and there are a lot of them that are like this, ask them to fit a curve to a set of data. So this one is asking them to fit a curve, or sorry, a linear function to this set of data and a quadratic function to this set of data. So this is crop yield as a function of density for the quadratic function. And I've used this example quite a bit, and students are always amazed when they see these numbers. CO2 levels per year, how are they going up? Are they going up in a nice linear fashion? They're supposed to discuss what's going on there. And they're also supposed to talk about why this one is better modeled by a quadratic function, because how the data goes up and then goes down. So the student who did this one answered the question about the linear regression. They put their line on the scatter plot, and you can see they did a little calculating on a piece of paper, and then kind of cut and paste it into the project. So this one, the coefficients for the value for A are very small, so they had to work with either scientific notation or actually write out the number. So for some of them, that was kind of difficult because even though they're trying to solve a quadratic equation, the numbers were really messy to work with. So that's why I kind of suggested to them, instead of looking at the equation itself, why not look at a graph and solve it that way? That would be another option. So the student corrected it. They went ahead and included their units. Sometimes units are neglected in these problems. And then you can see little notes that they put to the side there. And then here is the calculation of A, B, and C in the quadratic model. As you can see, they use Desmos. And then when they correct things that look good, there's no reason for me to comment on them. I just put other comments on things I want them to correct. So that makes the grading part a little bit easier to do. And then the third project, and these are all recent ones, these are just turned in by students the last month, is other polynomial function models. So the one I like to use here has to do with rock bass length as opposed to their age. So rock bass length as a function of the number of years. So if you look at the original data in this problem, they're supposed to answer why the question posed says, why is y not a function of x? If you look at the individual entries here, you can see some repeated numbers. So they're supposed to talk about a definitional function. So they had to come up with a linear or a cubic function that would fit to the data in this example. And then the second part of this, there's a missing picture here, but you've probably seen this one before. You take a rectangle, you take squares out of the corners, fold up the sides, and then you make a box without a top. And you're trying to figure out how big can the box be volume-wise. So that's a third degree polynomial function as well. So the student who did this, and I picked this example because you can see they kind of took my original project and just kind of cut and pasted their own writing in there. So that's another option for them. They shouldn't use red because red is my correcting pen, right? So they had to come up with models for both the functions. So the student came up with the good linear model and then the good cubic model. As I think you can see with the data, the cubic model is actually a better model for this one. We don't talk about the R and R squared values that much in college algebra. It's more of a look and say, is this one better than this other one? So they're supposed to say that this one looks a little bit better because it looks closer to all the data points. But one of the goals on this one is to think of the third degree polynomial function. If you're trying to solve an equation, if you're not able to factor it, how do you solve it? It's really hard to solve. So a graph is how they're expected to solve this one. So take your output and figure out the corresponding input fits. So this student did a pretty good job, except this problem again talks about restricted domains, just like that first project. And this student talked about numbers being bigger than 10. You know, for the box, you can't have the numbers be bigger than 0 to 6, because once you get to 6, you're taking too much out of each side. So they had to talk about why the domain was restricted. So they went ahead and corrected it. And I asked them to talk about why this is the maximum for the function when the function itself doesn't have its own maximum. And that's because of the original restriction. So they included all that. You can see they used Desmos and typed all their answers in. All right, let me stop sharing here for a minute. The other examples I wanted to show you are not, they're not technically technology projects, but they're ones I have developed for, we call it Concepts of Math. It's our Math 110 class. It's the first gen ed class that they can take with transfer level class. And I had done projects in that class before, but I had not done a lot of projects for each of the topics that we're covering. I think I may have done 2 or 3. So I don't expect them to use technology, but I do talk about where technology would be helpful. So in terms of graphing something or coming up with a picture for a set of data, things like that. So I want to show you a couple of those examples, if you don't mind. Because I really like some of these questions. So this is a class I sometimes like to teach when the students are doing well. Okay, so here's my first project in this class. It's about estimation in large numbers. So these are 4 questions. How many Post-it notes does it take to cover your friend's car? Okay. Second question and third question are a little bit more boring. It says, is it worth it to drive to another gas station that's 30 miles away because their gas is cheaper? And then, is it cheaper to use your own water bottle and fill it up, or is it cheaper to buy bottled water? So they have to do some research, come up with prices, compare and contrast. And then one of my favorite problems is number 4. How many boxes of your favorite cereal will you need if you want to completely fill the seating bowl at the U of I Assembly Hall? So, and of course, you've never been there, right? So you have to give them a picture. So, looks like the flying saucer that, lands in the middle of the cornfield at U of I, right? It's called the State Farm Center now. I still call it Assembly Hall. I'm sorry, I'm old fashioned. So guess what? One of the things students kind of misunderstand about number 4. They take a box of cereal, they put it in a seat and say, okay, I need about 15,000 of these. It's like, no, that's not what the question's asking. It's take the cereal, pour it out, fill up the bowl. So we talked about that. And that's why for these problems, or for these projects, they actually do rough drafts. I give them some hints and some suggestions to improve. And so for this one here, I don't know if there's a real formula to find this volume. I mean, it doesn't look like a sphere, but kind of like an ellipsoid kind of thing. I also give them another picture on this one. So here's what the inside looks like. And this is where the estimation part comes in. They're supposed to kind of figure out how far is it from like here to here. And we're just filling the seating bowl. So the seating bowl only goes up to right about here. So this student, this is actually one of my current students, answered all the questions. So, oops, this is a little further down. So got the dimensions of the car, got the dimensions of the Post-it notes, did the proper quotient and said I need 5 packages of Post-it notes. And you can see everything is written out. It's written out very nicely. They did numbers 2 and 3, compared the number of bottles of water they would drink per day to filling up their own water bottle. And they actually did number 4 correctly as well. I went ahead, I told them they could use half a sphere if they wanted to. And then they had to figure out what the radius was going to be. You know how many boxes it takes to fill up the seating bowl at Assembly Hall? 66 million boxes, approximately. That's a lot of cereal. That's a lot of cereal. So I hope they had some fun with this. It was kind of hard to tell since this is an online class, but you can see the types of skills they're supposed to be demonstrating here. So estimation, working with the large numbers, trying to figure out what these measurements are because you can't actually get there and measure them. So the student did a really good job with that. Okay, and here's another project I do with them. This is about probability. That's one of the topics that we do. So I decided to do a 3-part project for probability. The first part is they had to come up with a probability simulation that was going to simulate 4 different events. One of them is tossing a coin 100 times. One of them was to roll a 6-sided die 200 times. One of them was to select a numbered ball 1 through 12 400 times. And then everybody's favorite problem, tossing 2 fair coins, not just one, but 200 times. And so this is one where I suggested that they use random number generators that they can find online, or some calculators have them as well. They had to come up with their own system. How am I going to simulate this? So that was question number 1. And then who doesn't like lottery questions? So what's the expected value of winning the lottery? That's a question we ask a lot in this particular class. So Lotto, Mega Millions, so working with the idea of expected value there. And then my favorite, I found this one, somebody else had done this problem, roulette wheel. And a lot of students say, I've never played roulette. Well, here it is. I explain everything for them here. So got all the slots, 0, 0, and 0 are the green ones. You got the red and the black ones. And what's interesting about this project, if you played roulette before, what's the probability of landing on a red space? Is it 50-50? It is not. It's 18 out of 38. And that's how they win their money. It's never 50-50. That's not how casinos work. That's one of the things they kind of take away from this project. So I give them a bunch of different bets they have to take a look at and do expected values for those bets. Right. So this student here, I picked this one because they actually showed their coins. I didn't expect them to do that, but they showed them. Here's heads, tails, tails, heads. So they did some type of online random flipping thing, and they, here's heads, tails. There it is. Of course, they graphed it by hand, but anyway, that was still nice little juxtaposition there. And then here the die, you can see the die rolls there. The next one about selecting the numbers, that was a little bit more boring. They just listed all of their numbers after they had generated their rolls there. So there's the graph. And then for the flipping of the 2 coins, they went back and did the exact same thing. They got pictures of the coins, and then they were able to get a graph of that. So that was really nice how they did that. Then they had to answer some questions about probability. They didn't do as well with the lottery one as I was hoping. You saw they didn't get a perfect score, but they did a pretty good job with the roulette wheel. So this number right here, 0.05, if you've never played roulette before, all the options for betting for roulette that were listed in this project had the same expected value, negative 0.05 for the player. And so they're supposed to say at the end, what does that mean if your expected value is negative? So putting everything together in the end, saying, yes, on average, I lose 5 cents every time, which means the casino gains 5 cents every time. And that's how casinos work. So, all right, then let me show this one real quickly. Some of us teach graph theory now in Math 110. So this is a project involving graph theory. And this is a more personal project for me because they were supposed to take the map of the Rome subway system and plan a trip. And the reason I picked the Rome subway system is because it's not as complicated as some of the other ones like New York and Paris. And I've actually been, so it was, like I said, it's kind of personal to me. And you can look at these places and go to, this is the train station, this is the airport right here. They had to plan a trip and go to a bunch of these different landmarks. So, and I had been to a lot of these. I've been to the Colosseum, I've been to the Trevi Fountain, been to the Vatican. So it was really nice to kind of put this one together. And if no one has ever been there, I included some pictures for them. So Colosseum, Trevi Fountain, St. Peter's, and that is the, I always say it wrong, that is the Pantheon. Pantheon, yes. Get it mixed up with the other one. Okay, the next question they had to do is they had to take a map of the interstate system in Illinois and turn it into a graph theory map where the vertices are cities and the edges are roads connecting cities. Now, it's pretty complicated up here by Chicago, so what I asked them to do was take these distances and turn it into a map. So there's only a couple of ways to get to Chicago instead of all those other ones, so it makes it a little bit easier to do. And then they had to come up with some trips around Illinois. So I thought that would be interesting for them. This map shows a bunch of historic sites. So they'd stop at some historic sites. Carl Sandburg Home in Galesburg, Vandalia State House, Lincoln Trail Monument. Some of these I've been to, some of them I've not. Like most people, I've only been to most of Illinois on this side of 55. So I haven't been to U of I too much. So pretty much above this line and below this line. That's me. That's me. So they had to come up with, if you know some of the graph theory, they had to come up with Euler and Hamiltonian circuits. So starting and ending in the same place, visiting a bunch of cities, only visiting them once. So that was a good exercise. And then do what's called a minimum distance spanning tree. So this student right here, as you can see, got a really good score. Drew out everything nicely by hand, planned out their time in Rome, put everything together on a nice graph theory map here for the trips around Illinois. Came up with their own individual trips. You can see how well it's marked on each of those. And this one here, if you're familiar with Euler circuits, the map I gave them was not Eulerized. You have to connect a couple of the cities with odd vertices. So these two, or these extra edges you see here, make all the vertices even. And that means you can do a circuit. You can start in one place and go over every single edge and then end in the same place. So come up with that circuit. And if you've worked with spanning trees before, a spanning tree connects all the vertices with an edge. And you do what's called a minimum distance spanning tree. So these distances between cities, every city you can get from one to another with one of these trips that you see here. And that's what we call the minimum. So all the distances you see here were the smallest possible. So that was the last project. That's the last project. I wanted to show you those because those are more recent and I didn't get a chance to share them last year. So like I said, those weren't really technology projects. They're more projects based on those individual units.
Where do you get your projects?
I have lots of books in my office, but now I've been able to search online too, because I can kind of do, the graph theory one was kind of a hybrid. Somebody else had done a project with the going around a particular state. So I kind of adapted it to Illinois and just found the proper map and then was able to make it work the way I wanted it to. So, and just different textbooks, you know, when you've been around 30 years, you see a lot of things. So those first ones with the estimations are from, I think, our current Math 110 textbook. So, okay, so I've talked about that.
John, I was curious. I had a project on a roulette wheel myself this semester in my stat class, and
Oh, nice.
one of the, so that was fun to see. I had a couple of students come in to my office and you know, they had started some work and they wanted help on the parts they didn't know how to do. And I found myself in a tension there of like wanting them to succeed and wanting to help them, but also not wanting to, you know, do the project for them.
Exactly. Yeah.
So
that's always a hard. It's a hard.
How do you
line
handle
to,
that tension there?
Yeah, it's a hard line to draw. It's like you want to. You're happy they're interested, they want to know what's going on, but you don't want to show them too much. It's been a little easier being online because most students will not ask you unless they're really, stuck with something. And it's usually, you still don't get the question, oh, I don't know how to do this.
Yeah.
I don't know, where do you start? Like, do you know what a roulette wheel is? Do you know red, black, numbers? It's, with the probability questions, that comes up a lot. Students who never played cards before, they don't know the suits or the kings and the queens and the jacks. So how are they going to be able to answer, questions like that? Or, to me, a lot of the sports statistics are kind of like that too. Like, well, I've never played sports before. This is not a fair question. So you try to, get questions from different, variety of sources. So that's why with the roulette wheel, I tried to, with the picture, explain what's going on with the picture and what happens when you spin the wheel and stuff like that. So
I like it. Thank you. Just suggesting to me, you tell them to go try before asking, and just to show their thinking where it's at right now, so
Yes.
we can get a window into that. That's
well, and then the other thing, we're like 5 miles from a casino, so I just say, hey, just go right down the
hey,
road.
meet me at the
right? Sit
casino.
down there.
No.
The paradise is right down the road. Just go.
That's
practice
right.
it. Like the cards are there too. Play a little blackjack and learn about
Bring your own
the
deck.
kings and the suits and
AOD.
yeah, it's perfect. Perfect.
So, and I had another question. I was curious. Do you ever do group projects or partner projects or anything like that? How does that work?
Not recently. I used to, when I actually taught the math for elementary school teachers class, we did a lot of group projects there, and there would be like a written component and a presentation component. I don't know if those of you teaching that class right now, do you do projects?
I do projects. I have a rubric for peer accountability. Started using that in the calc class though, because when you are going to assign a project, there's always like the workhorse, the tag-alongs.
Yeah, that's
and the
always
people,
a disadvantage with the group projects is everyone's
Yeah.
got their role.
And sometimes you have like a very assertive person who's like, I'm going to lead this thing and
Yeah.
nobody's going to. So, yeah, I definitely use an accountability, like peer-to-peer. So Purdy, since it's easy for me to give that to you since we work at the same place. But
Oh, great. Yeah,
I
that's,
do-
that is one of the disadvantages of the group project is you think there's going to be someone who's going to take over and doesn't want to get a bad grade, so they're going to do all the work, but you want the students who need to get focused, maybe to pair them with someone who can maybe help them get focused, and it's hard dynamic. I'm sorry, I cut you off there.
Oh, no worries. For my statistics class, I found that if I broke, because I do a general, like a final project at the end. So we do Excel activities throughout the whole semester, and then kind of revisit all of them at the end with a group, like a project. I have had them get all the data together as a group and get more data than they need. And then I have them pick parts of the data, and so that their final project isn't the same as anybody else in their group, but they all had to go together to get the data. So.
I remember doing something like that in the second semester for the class. I'd have them gather some data about the class, and they had to present when there was a poster session and things like that. I remember that being kind of fun, because then it's personal. So they're talking about things that they care about. So. All right, I wanted to give Brianda is going to share some what she's doing at her college, but let me just go quickly over. I talked about some of the benefits and some of the pitfalls. I have found that students have improved their writing and communication skills. I like the variety and the creativity and the solving process. I don't tell them how to do things, so every project looks different, and that's what I like about it. And they can use whatever technologies they want. The pitfalls, as I said, students not doing their own work. I can't get these projects to be the same length. That's been a problem for me. I don't want one to be more labor intensive than another. They're all worth the same amount. I usually tell the students, they're all about the same, they're just over different topics, and that's not entirely true, but that's what I tell them. There's
Are they
also,
all total worth like a 15% in the overall course grade, or how does that work?
each project counts the same. So if they have to do it like a total of 4, they can do any 4 that they want.
And then, so is your class on a total point system or weight category weights?
It's the written part is category weight, so like quizzes, homework, things like that. And then they have to do a certain number of these technology projects.
And so,
Except-
and that category of technology project is worth total overall 10%, or how much percent of that?
It's actually not a percent, it's just a number. They have to do a certain number of them.
Oh, so it's just a requirement in the
Right.
course. You have to do 4 of
Yes.
these. And if they
Yeah.
don't do 4 of them, then they don't pass the course.
Exactly, yes.
Oh, okay.
So it's 2 components, the technology project component and then the written component. And those 2 together give them their grade.
Gotcha.
So, yeah, that's what I'm saying. In terms of varying lengths, I don't want one to be easier than the other, so everybody's going to be doing that one. So
That one, yeah.
that's been kind of I try to make them look about the same length, but still working on that. And then, it's always, is it worth it to be doing this, from a work standpoint? I think it is. To me, I think it's a benefit. It's another way of assessing things. So that's my thought, but others, it's hard to convince other people here to do things like this because everybody's kind of set in their ways. And so it's nice to talk to people who are a little bit more open to trying things like this. So, right, and give Riante a chance to, I wanted to give her the opportunity. She's going to talk about what they're doing at your College of Lake County.
Yeah, just a
Okay.
couple things to highlight, kind of piggybacking on what you have and then what we're doing at our college. For myself, I do teach when I teach gen ed stats, I have a final project, and that's worth about 20% of their grade, and it incorporates all the components that we've done before. So they have an Excel activity, they have 5 or 6 Excel activities as they go through, and then the project is them gathering their own data and working through their own data and then analyzing it. So sometimes they're great and other times they're interpretive. And then in my Math for LED class, I do a project portfolio, and that because one project doesn't always encapsulate all the things that they're working on, I do a couple different things. I have some favorites, like right now they're doing a geometry glossary, and they take pictures. If I have 50 different things, they have to find 30 of them, define them and find them. And they're great in that. Later on, they say, I can't not see them now. And I'm like, hee. I won. And then in our college, for our pre-calculus sequence, we just started, we launched it last month. We created a Canvas course where all the teachers are invited to put and gather our active learning activities. So small projects, large projects, group work, all those kind of things, to pull it all together into one Canvas shell that allows all of the teachers to have access to everyone else's projects and active learning strategies, which I think is it's just at the beginning, but it's pretty exciting for us to try to pull all those for pre-calculus, college algebra, and trig, to get those all together.
Those 3 are all
Shows-
related, aren't they? Yes.
What?
Those 3 are all related, yes.
Yes, and so we have
Definitely.
we've organized them so that a teacher hopefully can upload anything that they have and give a description about it and how long it takes and all the handouts, and then teachers can come to it and take it for their classes too. So hoping.
That's one thing I would like to do more of, and here is do a little bit more collaboration on things like that. I just, we're all kind of doing our own thing, and like it's probably good, but more collaboration I think would be nice, because when we started these technology projects, there were 5 or 6 of us who were interested, and once I resurrected them. I maybe had one or two other people, but it's just me now. And I don't know if even this whole idea of projects is something that people want to start doing, or they've been doing, or I don't know. So that sounds like a good thing.
Just to create some different ways of assessing students. And I agree, you see
Yeah.
some really great work that you may
Yes.
not see in different areas.
Yeah.
So,
I just noticed like I said, with the projects, I've never seen two projects that are the same. That's it. And some of them are wildly creative, and some of them are just barely getting by, but they did everything you asked them to do. So they get a passing grade. And the other thing about the way I grade things is the number of projects they have to do. If they want to get a C in a class, they essentially have to do one project and get 70% or better. And that's it. So that's what they have to do to get a C. And there are some who don't even do the one project. And that was another thing you saw in the pitfalls, is the kind of the misunderstanding about, thanks, Jan. The misunderstanding about how things are graded. And it's been more of a problem online because, it's in the syllabus. You say, read the syllabus kind of thing, and students don't read the syllabus. That when this question comes up later and I say, okay, you haven't done any projects yet, when are you going to turn one in? You have to turn one in to get a possibility to get a C in the class. And some of them don't understand it, or the fact that they have to turn them in and get them revised before it's accepted. I had in college algebra this past fall 3 students who never revised a project. So they ended up getting Ds because they never turned in something that was acceptable. And I gave them, I think it was like a reminder a week for a while. And it was actually an online hybrid class. So I was able to talk to them as well. And it didn't make a difference. So it was kind of disappointing.
it's hard.
So looks like our time is about up. So thank you, Riante, for sharing what you're doing. And thank everybody else for coming, Christopher, Matt, and the others who had to leave a little bit early. I guess I don't really have anything else to add other than if you want copies of, I have my email here. I'll just put that up real fast. If you want copies of any of the projects, you can just send me a message at my email address right here. So like I said, I have projects for everything up through differential equations. So starting with the transfer levels, I don't have stats and I don't have linear algebra. Sorry, Christopher. I'm still developing those. But if you want anything else, I have them available. So you can go and send me a message. Anybody have anything else they want to share before we cut out?
I just want to say thanks for sharing your
Right.
ideas.
Thanks
Always
for
nice to
thanks for coming.
see what others are doing. So
And me, yeah, but I like
you
that's
too,
one of the
Riante.
things I like about Allerton is the whole sharing and seeing what other people are doing, and whether it's worked, whether it's not worked, and just people talking about what they're doing. It just having that discussion it's good.
That's right.
So
Very good. Very
right.
good.
Well, thank you all
Thanks,
again.
Jen.
Okay, thanks.
Appreciate it.
Have a good rest of your day.
Thanks, you too.